Oh, you are really study hard. Let's dive straight into the journey of mastering Python, from absolute zero to becoming a proficient professional. This is your roadmap. So, why Python? In today's tech landscape, it's not just another language. It's arguably the most versatile tool in many developers' arsenals. Need to build a web app? Python has frameworks for that. Want to crunch massive datasets or train AI models? Python is the go-to language there too. Its syntax is famously readable, which means less time deciphering cryptic code and more time actually building things. And the ecosystem? It's enormous. Think of libraries like Pandas for data analysis, TensorFlow for machine learning, or Flask for web development. They're all built on Python, saving you countless hours of reinventing the wheel. Plus, the community is massive, meaning you'll find answers and support almost anywhere you look. Finally, let's be real. Companies are hungry for Python skills. Mastering it significantly boosts your career prospects. Alright, let's lay the groundwork. Before you can build skyscrapers, you need solid foundations. We start with the absolute basics: variables and data types. Understanding integers, floating point numbers, strings, and booleans is fundamental. Then come operators, the tools you use to manipulate these data types. Next, control flow. This is where you tell your program what to do based on conditions, if statements, and how to repeat actions loops. Functions are crucial for writing clean, reusable code, avoiding repetition. And finally, core data structures: lists for ordered collections, tuples for immutable sequences, dictionaries for key-value pairs, and sets for unique elements. Mastering these isn't just about passing a test, it's about developing the fundamental thinking patterns needed for effective programming. With the basics down, we move into the core building blocks that make Python powerful. Modules and packages are essential for organizing your code into manageable chunks, promoting reusability and collaboration. File I/O is non-negotiable. You'll need to read configuration files, process logs, or save results, so understanding how to interact with the file system is key. Error handling using try, except, and finally blocks is critical for writing robust applications that don't crash unexpectedly. Then we dive into object-oriented programming, or OOP. Concepts like classes, objects, and inheritance allow you to model complex systems in a structured way, which is standard practice in large-scale software development. Finally, touch on decorators and context managers. These are advanced features that provide elegant solutions for common programming tasks like function modification and resource management, making your code cleaner and more efficient. Now, let's talk about the real power multipliers: libraries. Python's strength lies heavily in its vast ecosystem of libraries. First, the standard library itself is incredibly rich, offering built-in modules for everything from file manipulation to web services, often eliminating the need for external dependencies. But for serious work, you'll quickly lean on specialized libraries. NumPy is indispensable for numerical computing, providing efficient array operations that are the bedrock of scientific computing. Pandas takes data handling to the next level, offering powerful data structures and data analysis tools for cleaning, transforming, and analyzing structured data. When you need to visualize your findings, Matplotlib and Seaborn are go-to libraries for creating insightful charts and graphs. And for interacting with web services or scraping data, Requests simplifies sending HTTP requests dramatically. These aren't just nice-to-haves, they are essential tools for any modern Python developer. Python shines brightly in web development. You have two main paths: lightweight frameworks like Flask, which give you fine-grained control and are excellent for APIs or smaller projects, and the full-featured Django framework, which provides a batteries-included approach with built-in ORM, authentication, and admin panel, speeding up development for complex applications. Of course, you can't ignore the front end. HTML, CSS, and JavaScript are still king for the user interface. Python excels at the back end, handling server logic, database interactions, and business rules. Integrating databases is straightforward with support for SQLite, PostgreSQL, MySQL, and others. Building RESTful APIs is a common task, and Python frameworks make this easy. And if you need to pull data from websites, Python's libraries combined with web scraping techniques are incredibly powerful. Whether you're building a simple blog or a complex e-commerce platform, Python offers robust solutions. This is where Python truly becomes transformative: data science and machine learning. The ecosystem here is arguably the most mature and comprehensive. Scikit-learn provides a wide range of supervised and unsupervised learning algorithms, from regression to classification to clustering, all in a consistent API. For deep learning, TensorFlow and PyTorch are the dominant frameworks, offering flexibility and performance for building complex neural networks. Jupyter Notebooks are invaluable for exploratory data analysis, allowing you to mix code, visualizations, and narrative text in an interactive environment. A significant part of the process involves data preprocessing and feature engineering, cleaning messy data and transforming it into meaningful inputs for your models. Finally, once you have a model, you need to evaluate its performance rigorously and, eventually, deploy it into production. Python provides tools for all these stages, making it the de facto standard in the field. Beyond web development and data science, Python is a fantastic tool for automation and scripting. Think about repetitive tasks, managing files, renaming thousands of images, extracting specific information from reports, or even automating clicks in GUI applications. Python can handle all of this. Using command line arguments allows you to make your scripts flexible and reusable. You can automate almost anything from file management to complex web scraping workflows. Libraries exist for GUI automation, letting you control other applications programmatically. Scheduling these scripts to run automatically using cron on Unix-like systems or Task Scheduler on Windows is straightforward. Furthermore, Python's ability to integrate with other systems via APIs, databases, or calling external command line tools makes it a powerful glue language for building complex automated pipelines. It's about taking control of repetitive work and freeing up your time for more creative endeavors. Once you've mastered the fundamentals and core applications, you can push the boundaries with advanced topics. Concurrency and parallelism are crucial for building high-performance applications. Python's threading module is useful for I/O-bound tasks, while multiprocessing leverages multiple CPU cores for CPU-bound workloads. Performance optimization is always important. Learning how to profile your code using tools like cProfile and then applying techniques like algorithmic improvements or using faster data structures can yield significant gains. Metaprogramming, writing code that generates or modifies other code, opens up powerful possibilities, though it requires careful consideration. For digit performance, consider Cython or PyPy, which compile Python code to C or use a just-in-time compiler respectively. And finally, contributing to open-source projects is a fantastic way to deepen your understanding, improve your coding skills, and give back to the community that has given you so much. The journey doesn't end here. Continuous learning is key in the fast-evolving world of technology. There are tons of online resources, courses on platforms like Coursera, Udemy, and edX, and tutorials galore. Books like the official Python documentation, Python Crash Course, or Automate the Boring Stuff with Python are excellent for structured learning. Don't underestimate the power of communities. Stack Overflow, Reddit's RPython, Discord servers are invaluable for getting help and discussing ideas. The best way to solidify your knowledge is through practice, build projects, contribute to open source, solve problems on sites like LeetCode. And keep learning, follow Python news, attend conferences, and stay updated with new language features and library releases. The Python world is constantly evolving, and staying curious and engaged will keep you at the forefront.